Hey, Buffy. Let me introduce you to the speakers for a little bit, sorry, to the audience, and then I will ask you to share your presentation. So yeah, Buffy is the co-founder of CarbonRE, and the CarbonRE is an AI startup that's using reinforcement learning to help the net zero transition for manufacturers of cement, steel, chemicals, glass, and other similar industries. These sectors are extremely emission heavy. They represent over 20% of global emissions, and CarbonRE uses AI and process improvement techniques to improve their efficiency and reduce their emission intensity, while also doing that profitably. Yeah, prior to founding CarbonRE, Buffy's been working on harnessing AI for climate at Element AI, and prior to that, also as a senior advisor at Amnesty International. So very extensive, interesting background. Yeah, on to you, Buffy. Please share your presentation.
Thank you. Can you see my screen?
Not yet, actually. You might need to press share again.
Okay. Okay. Yeah. I'm just sharing it. Apologies.
There we go.
Smooth start. Okay. Well, thank you very much for the introduction. So I'm the Chief Operations Officer and one of the co-founders at CarbonRE. I'm going to run through this short presentation, which will explain a little bit about what we do and why and our approach. I have to say up front that I am not a machine learning expert, so I'll ask for your forgiveness and my limited technical knowledge. But I will share some insights about our experience so far as a startup introducing cutting-edge technologies into large and transient industries. And I'll try and leave a few minutes for questions at the end. So first, a little bit about the team. As just mentioned, I worked previously at Element AI, which was a big Canadian AI startup which scaled very quickly and was acquired by ServiceNow last year. I worked there with Sharif, who's the CEO, and together previously we were both at Amnesty International. And while we were working there, we started working on a project with Daniel Summerbell from the Institute for Manufacturing, which is a centre of expertise in industrial sustainability at Cambridge University. And it's his operational improvement techniques focused on reducing emissions in energy-intensive manufacturing, which is forming the basis of our product. Some of the audience might have heard of Aidan O'Sullivan. He's our fourth co-founder and associate professor and director of energy systems and the Energy Systems and Artificial Intelligence Lab at the UCL Energy Institute, quite a mouthful. He's also a Turing Fellow and the AI for Climate Chair of the UNESCO Centre for AI. Aidan has been pioneering applications in deep reinforcement learning to industrial energy problems, and we're making most of his expertise in our current product. We also have a brilliant team of advisors, including John Shaw-Taylor, also from UCL, and he's a director of the International Research Centre at the International Research Centre for AI. And I gather he's pretty well known amongst the AI community as well. We also have Tabitha Goldstub, who is the founder of Cognition X and chair of the AI Council in the UK. Steve Evans is a leading expert in industrial sustainability at Cambridge University. And last but not least, Jordan, Richard and Sylvain are experts in startups, investments and go-to-market. And their insights have been just as invaluable as the industry and AI expertise for us as a nascent company. So that's us. So we're a climate tech startup focused on reducing carbon emissions in the foundation industries. This is a term used in the UK for energy-intensive manufacturing like cement and steel, ceramics, glass, chemicals and paper. And these industries represent $1.5 trillion in annual turnover a year and also account for 20% of global greenhouse emissions. And of that, cement accounts for 8% and steel 7%. So they are really significant for climate change. And what those foundation industries have in common is very high temperature processing stages for their core materials. That's about 14 or 1500 degrees Celsius. And that requires burning fossil fuels, and the carbon emissions are also released from the raw materials themselves as they are heated. But these are core industries and demand for them is growing. I know in the UK, we are seeing a big push for infrastructure projects as part of the post-pandemic recovery. And there is also a critical role for infrastructure in bringing communities out of poverty worldwide. So demand is growing, and we also need to reduce our global carbon emissions. I think everyone is aware of emerging technologies such as carbon capture and storage and green hydrogen, but these are many years of maturity and scale. In addition to all this, the foundation industries have a number of challenges from low margins, which can make them sort of small c conservative and a little bit risk averse in some cases. On top of that, they're facing carbon taxes and political and investor pressure to reach net zero, which is obviously very important. But together, all this represents an existential threat to many of the manufacturers. So what can we do about it? Our solution is an AI-powered cloud-based software platform that combines industrial process improvement techniques with deep reinforcement learning. So by minimizing variation in day-to-day plant performance to improve operational efficiency, we can cut energy costs by up to 8% and fuel-derived emissions by up to 20%. This in itself can save between 2 and 7 million per plant on an annual basis, depending on where the plants are based and where there are carbon taxes. Where advantages of software and AI comes in, unlike hardware, our solution does not require capital investments. It can be implemented very quickly and have immediate results in terms of costs and also emissions reduction. I think it's really important to state that we know that this technology is not going to get these industries to net zero, but it will help us get on the path to reducing emissions now and be better prepared for the new technologies such as carbon capture and storage as they come online. Also, there's an important point about the radiative forcing effect of so the more emissions that we reduce today, the more savings add up, which means less heat trapped over time, and that ultimately reduces global warming. And that means that 1 tonne of carbon saved today could be as much as 2 tonnes saved if we wait to 2050. So we think that our solution can have a global impact in terms of CO2 reduction. So how we do it? As I mentioned, our solution is based on Dan's research at Cambridge University, and he carried this out on 3 cement plants in the UK. His modelling before we introduced the AI showed that we can enable cement plants to achieve and maintain their current 90th percentile performance, meaning their best or near best performance, by controlling underlying variance within the operations that might be caused by fuel type or fuel mix or excess air ratio and a host of other performance parameters. And what's important there is that this means that the plant is not doing anything new or out of the ordinary or new equipment. It means we are simply using our software-driven recommendations to make that plant achieve its best performance every day. So the technology behind this, and where this goes beyond Dan's research at Cambridge, is bringing the idea of deep reinforcement learning. And that is what sets us apart from many of the other expert systems and similar types of approaches that are out there on the market. Aidan really is the best person to talk about the technical details, or probably anyone listening to this conference. But essentially, we are uploading the process data from our pilot partners and ultimately our customers to the cloud, and the system learns how to optimize the performance of the plant and develops tailored recommendations for the plant operator that helps them achieve that optimal performance more consistently. And this system is what we are calling the foundation platform. So we're keeping a human in the loop, at least for the initial stages of our product. And the main reason for that is that it cuts out a huge amount of the complexity and the risk and the uncertainty and resistance from industry of just going in and taking over somebody else's systems with an unproven new product. That does mean that the plant operators will have to make manual data uploads to the cloud initially, but this avoids us getting embedded in operating systems. And it also means that we're keeping control in the hands of the operator, which is important for building trust. So what we've done is developed this dashboard that recommends prioritized actions to the operator. And why that's useful for the operator is that they're dealing with huge amounts of complexity. They're really highly skilled people, but they're sitting in front of like huge, like 16 different screens with alerts going off every few seconds. And while they'll have, daily KPIs, it's simply not possible for them to process all that information and manage a vast array of parameters on themselves. So that's what our platform can do for them. And most importantly, it can show what the result would be of the actions that they're taking. So this slide shows an example of the user interface. It's just a prototype, but we know that the user experience is going to be vital in the success of our product. So we'll be working closely with our pilot and early access partners to get that right. And so what this means in terms of impact on business, the numbers have to be rough. But to give you an approximate idea, the wholesale cement is something in the order of about £50 per tonne, and our solution can save £1 per tonne in fuel costs and £1 per tonne in electricity costs. With carbon costs as well, that increases to about £7 per tonne. So this is as significant for big business margins as it is for the planet. So that's what we're trying to achieve with our first product. And I just wanted to end by sharing some of the things that we've learned as a startup moving from prototype to commercialization. We're still developing our commercial product. So we're offering low-cost pilots and early access programs to help us gain data and develop our products, get that crucial feedback from the plant operators, and help us establish a foothold in the industry. In terms of traction, we've been pretty successful early on. We ran a pilot in North America and engaged Siam Cement Group, which is one of the largest cement companies. And we're also in reasonably advanced conversations with about 8 or so other companies worldwide. But we've also, faced lots of challenges. The sales cycles are long. COVID-19, we were pandemic company. Even the 4 co-founders only met for the first time in April this year. And that has made the business development harder. Establishing new business contacts is time consuming at the best of times. It means lots of meetings and introductions and LinkedIn engagements and lots of patience. But the lack of face-to-face opportunities has impacted that. We've also met some understandable reluctance to freely share data, even historical data, and data sharing agreements can really take some time to agree and be reasonably costly in terms of dealing with lawyers. We're also facing with a really big mix of manufacturers in the same sector. There's some large innovative companies, global conglomerates that are leading the way, to smaller, digitally tentative ones, but that are being really pushed by innovation. So it's really helping to understand the drivers and the motivations behind the different companies for us to be able to proceed with them. I mentioned earlier that low margins can also mean a risk-averse culture, and that means that there is little room for error, which is always worrying for a startup. For example, we learned the importance of making sure that we get the data request right first time, very early on. Don't want to miss that trick. And we also need to stand out in a crowd. There are lots of emerging climate technologies, which means we really have to push the no capex, immediate impact aspects of our solutions. So some of our successes and lessons and things we're doing, we're focusing on direct introductions to potential customers. We're presenting at remote industry events. We're presenting at online conferences. We're organising our own e-webinars and also engaging with trade associations, which have credible networks. We had a profile in Global Cement magazine in May, which was surprisingly useful for opening up new contacts. And it turns out people really do read trade magazines. Who knew? So also really important to learn where to make our point of introduction into the companies. It needs to be senior people with business incentives, such as the CFO or sustainability officers. So pinpointing that person early on, and maybe not sort of spending too much time on the wrong characters, positions people that don't have decision-making power has been a lesson learned. We're highlighting the differentiation of the technical capability, particularly the use of deep reinforcement learning, and the credibility of our team has been a great door opener as well, particularly the AI expertise, but also the domain expertise, Dan's expertise of the industry itself. And finally, I just say it's really important to remember that the software solutions are just as much about the people as the technology. Just going into those relationships and understanding that. I think there has been always a fear of adding complication, risk of people losing their jobs, or a big upheaval to no benefit. And that's really what we're trying to look to avoid with our product, make it really straightforward, easy to deploy, no integration systems, and hopefully we can have impact really quickly. So I'll end there and have to take questions.
Apologies, I forgot to unmute myself.
Okay.
Thank you so much, Buffy, for another excellent talk. That's again emphasizing that to make an impact in climate as an ML professional, you probably should work with a domain expert, even though you might not necessarily absolutely have to be a domain expert yourself. But the domain expertise here is clearly critical. If AI skills are all you have, you better find a co-founder. So we have a couple of questions from people here. One I think you kind of touched on, which is what have you learned from breaking into a rather conservative field like manufacturing with a product sort of at the intersection of two novel trends, AI and sustainability. And I think
it's been interesting. But before Element AI, my background was in someone buzzing. Excuse me. My background was working with huge NGOs, so I'm actually used to that very slow bureaucratic dynamic, and I'm sure I both bring that expertise with us. So I think there's just really understanding the personal drivers and where the fear, it's unknown. My background is actually in change management, and that's really coming in a lot of very much use in this situation as well. So it's patience, it's really going back to basics, reassuring people. I think the approach that we're trying to take with building up that integration and systems, not taking over in the first instance and letting those plant operators have a modicum of control straight off is proving fruitful so far.
Got it. Makes sense. And one more question. We'll probably just have time for one more. What other similar problems in decarbonizing legacy industries do you think are not yet solved and are worth working on? I guess, what is something that you wish you had time to work on that is sort of along similar lines?
Well, in terms of, this is very much me with the business hat, and we're really focusing on the process optimization in the first instance. But I think we're with Dan and Aidan's expertise, looking at power matching and bringing that, making the most of when renewables come online and power switching. And I think that would be something that we would want to build on next. The process that we're focusing on at the moment is a small component of the whole cement manufacturer. Also, it would be similar with steel and glass, etc. But to build that out and actually have efficiency across the entire process, through the supply chain, but also to take into account sort of energy use as well.
Understood. Thank you so much. So we're over time, so we have to end now. But this was great.
Thank you very much.